This is 2013 FRQ number 4 in the non-calculator section. The figure above shows the graph of f prime, the derivative of a twice differentiable function on a closed interval between 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, which means that's a slope of 0, x equals 3, and x equals 5. The areas between these regions, between the graph of f prime and x-axis are labeled in the area in the figure above. So this is 2, 6, 3, and 7. Great. F is defined for all real functions and satisfies f of 8 equals 4. So this is a hint. If this is f prime, then what is f, right? It has a f of 8 equals 4. What does that tell me? It has the same relationship we had in the prior FRQs, where this is the derivative function, right? So this is f prime, which means f of x is equal to the initial value of 4, and then you have to start at 8 to whatever x value it is on your picture, right? And f prime is just the graph. And then f double prime is the slope of the graph. Okay, so keep that in mind. All right, for all values of x on the open interval between 0 to 8, for which the function f has local minimum, justify your answer. So for f to have a local minimum, f prime has to go from decreasing to increasing, which means f prime has to go from negative to positive, right? So this picture here has to change from negative to positive. Well, this is positive to negative and negative to positive. So this is the only piece right here at x equals 6. So f has a local min at x equals 6 because f prime changes from negative to positive. Okay, all right, next one says determine the absolute minimum of f on the closed interval between 0 to 8. Justify your answer. Well, we had a local min at 6. We don't know if it's an absolute. So because there is a closed interval, you got to check the endpoints as well, right? So part B says now you got to check. Now you check f of 0, f of 6, and f of 8. 0 and 8 are your endpoints, and 6 was the minimum you got from before. And so based on what we did before here, right, this is f of x. So what is f of 0? F of 0 is 4 plus integral from 8 to 0 f prime. Well, you can't go from 8 to 0, so it has to be 4 minus 0 to 8 f prime. Okay, so what is that? 4 minus the area from 0 all the way to 8. So that's 2 plus 6, because these are positive. This is negative, so minus 3 plus 7. Okay, so what does that give me? This gives me 8 plus 7, that's 15, minus 3 is 12. So 4 minus 12, negative 8. That's f of 0. Okay, next, this is 4 plus integral 8 to 6 f prime, following the formula 4 plus integral of 8 to 6. Again, backwards, so we can't do that. So 4 minus 6 to 8 f prime. 4 minus, so from 6 to 8, I have 7 here, which is awesome. This is negative 3, so that's my answer at 6. Last but not least, 4 plus integral from 8 to 8 f prime. Well, 8 to 8 has no intervals. There's no area there. Therefore, you equal to 4. All right, so which one is truly my absolute minimum? It is actually at f of 0, so at 0. So absolute minimum of negative 8 at x equals 0. So my minimum before was actually a local one, definitely not an absolute. Okay. What open interval contained in 0 to 8 is a graph both concaving down and increasing? Explain your reasoning. All right, so let's see. I want concave down. What does that mean? That means that f double prime is negative, which means in my picture, the slope has to go down. Okay, all right. What else? I want increasing. Okay, so if it's increasing, that means f prime is greater than 0. What does that mean? That means in my graph, it has to be above x-axis. All right, so which part of my graph is above the x-axis? Well, all of these, right? But it has to be decreasing. So this is decreasing, increasing, decreasing, increasing. So decreasing here to here, decreasing here to here. So the interval is 0 to 1, and then the interval of 3 to 4. 3 to 4. All right, so those are my intervals. You can write 0 to x 1 and 3 x 4. Okay, that's it. And that was shockingly easy. All right, part D. The function g is defined by g of x equals f of x third. If f of 3 is -5 third, find the slope of the line tangent to the graph of g at x equals 3. So that's just a really convoluted way of saying, hey, find me the derivative of g, right? And then plug in 3. All right, so this is just chain rule. You have g of x equals f of x to the third. Okay, so g prime of x equals chain rule. Bring down the 3 f of x squared. Then you have f prime of x, right? Okay, now I'm ready. So g prime of 3, what is that? 3 f of 3 squared f prime of 3. Well, it said in here f of 3 is -5/2, so -5/2 squared. What about f prime of 3? Well, f prime of 3 says, look at the graph, look for when 3 is. 3 is 4, so times 4. That gives me 3 times 25/4 times 4. That gives me 75. That's it.